Okay, so going over chapter 7 quiz. Number 1 and number 2 I was very surprised with. Usually those are easy questions. But again, back to the point of some people are getting things like y'all aren't making connections like what parameters are, what standard deviation, that kind of stuff. So overall, I'm going to talk through these. Versions are different, but problems are the same for the ones that the people who are in here today. I guess. Number 1 and number 2. One problem is about telephones. If you just say it has to be residential, it has to be in Los Angeles, and it is not people with phones, and it is not phones, it is the actual phone numbers. Because if you have phones, one number can have a bunch of different phones that are connected to it. If it has people, a lot of people can be connected to more than one number, so it's specifically residential telephone numbers in Los Angeles. And the sample is 100 residential telephone numbers that were randomly dialed by the firm's random digit dialing device or something. I wasn't super picky on that this year. So what does the word parameter mean? What is a parameter? A number that describes what? Population. So talking outside of this problem, what are some examples of a parameter? Symbols. What's another one? What's another one? And then some people put that in there and some people don't. So what are examples of a statistic? What else?
S.
And then we have sigma p hat, mu of p hat, sigma of x bar, mu of x bar. I don't really talk about those as either one of those. It's of the sampling distribution. The sampling distribution is made up of a whole bunch of statistics, but all of them would be included, which would be parameters, so I don't talk about it. Either one of those in this list. So the one that's talking about the phone numbers, is 48% a mean or a proportion? 48% are unlisted. Is that a mean or a proportion? A proportion. So don't write u equals and don't write x bar equals. Which one is talking about? And the easier way for me to do it is figure out which one's talking about the sample. So our sample size is 100. So which one is talking about those 100 people? 100 numbers? 48%. So 48% is your statistic. Yes, no, good. So p hat is 48% because of that. 48%, 0.48, either one's fine. So the other one is talking about all Los Angeles residential phones. So that's your parameter, so that is p. In the other problem, whichever one it is, 1 or 2, this is what I was talking about being specific. Large container of ball bearings is not fully correct because then your individuals are containers. It's all ball bearings in that large container because then your individuals are ball bearings. I counted off 1 for that. I think I wasn't as picky as I usually am. Is this problem talking about means or proportions? Means. How do you know this problem is talking about means? Because it says the word mean. So should you ever put p or p hat for your answer? No. Notice things like this to help you. Like these should be catching easy mistakes by looking at stuff like this. And then make sure you include your units. So our 100 ball bearings is our sample. So of those 100, which mean went with that one? The 202.5009, so that is our x bar. The other one was talking about the entire, all of them in the container, so that's your population, so that's your parameter. The parameter would be mu equals 2.5003 centimeters. Number 3, what is a sampling distribution of x bar? is the distribution of all values of either the mean or proportion written out in context, or all possible samples of n individuals. So this one would be the proportion of young adult internet users. This would be the distribution of the proportion of I'm thinking what I said. Yeah, young adult internet users, the proportion of young adult internet users who watch online videos for all possible samples of, oh, I'm reading the wrong column. Okay, I'm reading the wrong column. So this would be, that's what I was trying to figure out.
3 is the 100 students
at this high school, okay. So this is the distribution of proportion of students who did all their assigned homework last week for all possible samples of 100 students from this particular large high school. Questions on that? A lot of people just weren't ready for that, I think. All right, so step, or number 4, the 4th step. What is your population? All young adult internet users ages 18 to 29. And you do not include watch online videos, because watch online videos is considered our what? Our success is the one that's watching online videos is the success. So our sample is the 1,000 young adult internet users that were randomly surveyed. P is the proportion of all young adult internet users ages 18 to 29 who watch online videos. And then you're finding P parentheses something with P hat, depending on which version you have. So then within do, you have to have mu of what? Equals, which equals, and that was for everybody with 0.75. So this right here, sigma of p hat. Sigma of p hat just means of the sampling distribution of p hats. That does not mean I plug p hat in somewhere. So then when you do this, I do not plug p hat in right there, because that would change if I had different values. We don't want it to change. So I'm plugging in 0.75, 0.25, 1,000. This will tell you. And when I find that number, I have to write what to the side? Because of 10% condition. What happens past there is chapters ago. If you haven't figured that part out yet, you need to, because we use it like every problem from here on out. The P parentheses part, but all the problems are different, so I'm not going to go over exact answers. And then your interpret sentence. And if you miss the interpret sentence, then you just kind of shot yourself in the foot for 4 points. Like I said here, use the sentence. Now use it. So if we randomly selected 1,000 young adult internet users ages 18 to 29, when P does equal 0.75, we would expect the probability of whatever the problem says in context, users to watch online videos, to be the number of the answer. Make sure you draw and shade your curve for every problem. 5 is the same thing as 4, but just with different numbers. All right, 6 specifically says, consider the center, consider the shape, consider the spread. And I'm dealing with sampling distribution of p hat. What is the only thing I have that deals with center? So mu of p hat, which equals what? P, which equals 0.75. If I change n, what here changes? Nothing. So what happens to your center? Stays the same. If I do spread, what's my spread? Sigma of p hat. N is in the bottom. If I make n 4 times larger, what happens to your standard deviation?
2 by 1 half.
Not 1/2, but
Square.
square root 2. And some people plugged it in and actually found that number. What's the only thing that I have that deals with shape? And I didn't mention it when I went through the 4 step. Whether or not it's normal. Well, if I'm checking for normality for proportions, I'm doing n times p, n times 1 minus p, and making sure that they are both greater than or equal to 10. Well, if I plug in 1,000 and they're both greater than or equal to 10, if I plug in 4,000, are they both going to be greater than or equal to 10? So what happened to the shape? So either it stays normal or it gets more normal or more bell shaped. Some people said that, and that's fine, but it's still normal approximation. And then with number 7, if it says what is the largest possible sample, what variable am I solving for? Little n. You live in a small town with only however many residents. So that is your population. So this is the equation that you're using. You plug in the population there and solve for this. You take population divided by 10, and that's how big of a sample you can have.